Okay, welcome back uh, to the second lecture of this multivariate calculus. Myself, Krishanu Deashi. I belong to the Department of Basic Sciences and Humanities, IIM Kolkata. So, in this lecture, let me recap what we have learned in the last lecture. That we have know that calculate is, if I break down this term, we can have two terms, that is multivariable and calculus. In the calculus part, that you already seen in the already you have studied this calculus in your class 12, 11. Now, also in the first year, you also know about the calculus. Now, here in the calculus, you have studied the limit, continuity, differentiability, right? So, in this in the second lecture, we'll talk about the limit. Limit, how we can define the limit for multiple variable or multivariate function. Okay. So, for the let me recap that what is the limit of a single variable. So let's we have x and y axis, right? And if you have one function, let's say y equal to fx. Now, if I want to find out the limit of some point that is some, let's say a, and I have to see whether at this point whether limit exists. It means that with that the left hand side, if I approach this point from the left hand side, that is exactly equal to that limit if I go from the right hand side to that point of this a, right? Then if the two limits are equal, left hand side limit and right hand side, then I can say that limit at the point a of this function y equal to fx is exists. Now, in the case of multivariable, if I see that 3D plot, right? You have x and y, two independent variable, and I will plot them in that horizontal plane and z in the vertical axis. Okay. Now, suppose there is one surface. So here you will get surface as we are talking about the multiple variable, and let the equation of the surface is z equal to some function of x and y. Now here I want to find out the limit at some point that is belongs to the xy plane, because x y are the two independent variable, and I want to see that a and b be that particular point, and I want to see that whether the limit at that particular point it is exist means. Then if I see in that in the only the single variable, I can just move from the left hand side and right hand side. So here either I can approach to this point from this direction, right? Or I can approach to that from the right hand side direction to this point AB, or I can move this direction parallel to the y axis. This is also parallel to the y axis. Also, I can reach to this point this way also, right? Also another way. So there are also I can move by using different curve, right? So I can approach to this point various path, not only on the two path, like in the for the single variable. For infinite path, I can approach to this point, and if the limit of all these points are equal, then I can say that limit exists at this point A and B. That is the geometrical way I can say. Now, like for the single variable, uh, I know that if there is one function fx has some limit L as x tends to A, okay, then symbolically we basically denote this one limit x tends to A fx equal to L. For the case of multivariable, we have two independent variable x and y, and suppose that limit of this function is L. If I approach x to A and y to b, then how we can write symbolically? So it will be like this one. So x tends to a, also y tends to b, f of xy. Okay, as there are two independent variables, so we will write to one by one, then f of xy equal to L. Now in the terms of neighborhood, that we also know in the case of single variable, so fx is the function, has limit L as x tends to a, then for given any epsilon greater than 0, there exists a delta greater than 0 such that mod of fx minus L is less than epsilon whenever 0 less than mod of x minus a less than delta. Now similarly, we can have definition for the multiple variable where you have the function of f of xy has limit L as x tends to a, y tends to b. So in this case, I can write that it will be norm of xy minus L is less than epsilon whenever 0 less than x minus x comma y minus a minus b is less than delta. So similar way we can define the limit in terms of neighborhood, right? So here basically we are excluding the point a itself, and here we are excluding the point a and b. That is basically, for the case of limit we have to exclude the exact point x equal to a, so that's why it should be 0 greater than a. Some important result of the limit, the similarly you already know for the single variable. So here if this function f of xy has limit L as x tends to a, y tends to b, and another function g is there whose limit x tends to a, y tends to be equal to m, then I can write down the limit of this function f x y plus minus g of x y, the sum of the two functions, as L plus minus m. Similarly, the same result hold for the multiplication of these two functions, also the division, also the limit, also this hold. The same similarly result also for the single variable. So here also you can see that all the result hold for the multiple variable. Also here you that for the last one there is caution that n should not be 0. The limit of g of xy should not be 0. So that's all the second lecture. See you in the next lecture. Thank you.